Hello everybody. Today we are going to see super mesh and super met. First we'll see the problems in super mesh. Determine the current flowing through the 3 ohm resistance using mesh analysis method. So if you look at the circuit, in this circuit we have two different types of sources. One is voltage source, other one is current source. So if the sources not look identical, so we will consider that type of circuit is called as a either super mesh or super node. Based on the question, the values through the resistance, either voltage or current can be determined. So since in this particular circuit we have two different sources, one is voltage, other one is current. So in this question they asked to find out the current flowing through the 3 ohm resistance using mesh analysis. So in ordinary mesh analysis method, this problem is difficult to find it out. So we can apply super mesh. So in the right hand side, the modified diagram is given. So you can see as per the original circuit, we can see 3 loops. But since we have a current source between loop 1 and loop 3, so we can virtually imagine the circuit and we will take it as the loop 1 and loop 3 as considered as a single loop, but current flowing through the loop 1 is as I1 only and the current flowing through the third loop is I3 only. So based on this assumption, we can find out the equation as per the KVL. Then finally, we'll find out the current flowing through the 3 ohms. So here as per this circuit, we have I1, I2 and I3 current. So now we can write the equation. So assume that current source and the 2 ohm resistance, that is 7 amps and the 2 ohms are connected in series. So it is virtually considered as it is not present. So we have to take that loop 1 and loop 3 as a single loop. So we know how to apply the KVL equation for a single loop circuit. So same procedure we can apply the KVL and write down the equation for this. So as per the KVL, the voltage rise equal voltage drop in the loop. So 7 volt is equal to I, the 1 ohms resistance. The 1 ohm resistance is the first one. So current flowing through the 1 ohms is one I1 and I2. So both are since in opposite direction. So I1 minus I2. Then you can see the direction of the current now, because since we are virtually eliminating that 7 ohms and 2 ohms, so that is not present here. So next we will be taking as the 3 ohms resistance. So once again 3 ohms current is I3 minus I2. You can see the direction of the current. Based on the direction of current, the I3 minus I2 will put. Then finally we have 1 ohm resistance 1 into I3. So finally the equation will become 7 ohm 1 into I1 minus I2 plus 3 into I3 minus I2 plus 1 into I3. So we got this equation. Now expand this equation, I1 minus I2 plus 3I3 minus 3I2 plus I3 equal to 7. Then simplify the equation. So finally we got I1 minus 4I2 then 4I3 equal to 7. Now this is our first equation. Now we'll go to the second equation, that is loop 2. We'll go to that loop 2. Since as I already mentioned, we have there are 3 loops, but we are just virtually eliminating the current source branch. So we have only one loop, that is 1 and 3 will be merged and it will become a single loop. So now it is only 2 loop circuit actually. So the first loop is over. Now we are going to find the second loop current. So to apply the once again KVL to the I2. So 2 I2 plus 3 I2 minus I1, since the current direction is in opposite, I2 minus I3 plus I2 minus I1 equal to 0. Since there is no voltage source here, so we are putting this as 0 here. So once again expand the equation, simplify, then we will get the equation number 2, minus I1 plus 6I2 minus 3I3 equal to 0. Now we have equation 1 and 2. As per the condition, we got 2 loop, 2 equation we got it. But the branch what we eliminated, no, we should not eliminate totally from the circuit. So we have to consider the current flowing through the sub ohms. So that is nothing but I1 minus I3, because I1 is incoming, I3 is outgoing. So I1 minus I3 is a 7 amps current. So that is also we have to put. Now we have three equations. So 1, 2, 3. So all these three equations solve this three equation. Then we will find out the current as 9 amps, 2.5 amps, and I3 as 2 amps. Since in this question they asked to find out the current flowing through the 3 ohms. So current flowing through the 3 ohms is nothing but I2 minus I3. So I2 is 2.5 and I3 is 2 amps. So subtracting we will get 0.5 amps. So this way we can find out the current flowing through the 3 amps using mesh analysis. So this type of problems is called super mesh. Why? Because there are the sources are not identical. So the sources are different here. Whenever the two various types of sources is used, you can apply the super mesh in this way. We'll go to the next problem. So determine the current flow into the 4 ohm resistance using mesh analysis. Once again, if you look at the circuit, we have two different sources. One is voltage source, other one is current source. So the current flowing through the 4 ohms is asked in this question. Now virtually eliminate the 6 amps and the 2 ohms. Then we will consider as that 2 loop become now one single loop. So once again apply the KVL for the entire loop. So we already know the first loop current is I1, the second loop current is called I2. Since we are eliminating the 6 amps and 2 ohms virtually, so we have single loop. So the current flowing through the 6 ohms is I1 and current flowing the 10 and 4 ohms is I2. So apply KVL. So 10 equal to 6I1 then 10I2 plus 4I2. So equal to 10. So this is the way we can get the equation. Once again simplify the equation, we'll get 6I1 plus 14I2 equal to 10. So this is the equation 1. Then the virtual line we eliminated, no, that we can bring it out here. So I2 minus I1 is a 6 amps. So now solve this equation, we'll get the current in I1 and I2. So I1 is minus 3.7, I2 is 2.3. So, but since in question they ask the current flowing to the 4 ohms, we know the current flowing to the 4 ohms is I2. So now I2 is 2.3. So that current we put it as 2.3 amps. So the solving of the two equations are given in the previous videos. So the people who are seeing the videos, you can refer the previous video to see how to solve these two equations using calculators. Next, let's go to the supernode method. Supernode first question. Once again, if you see, then we have the three sources, but two different not identical one. One is voltage source, another one is current source. So the question that determine the current flowing through the 4 ohm and 2 ohm resistance using nodal analysis that they has mentioned, but they are not mentioned whether it is a super node or super mesh. Simply they are mentioned as a nodal analysis method. So by looking at the circuit, we have to go for the super node because there are two different sources are used here. One is current source, other one is voltage source. So since we know the node, we have to find out the node. What is the node? So more than two branch joining point is called node. So here we have only two nodes here. So that is mentioned here as V1 and V2. As per the KCL, current flowing through the 4 ohms is I1 and current flowing through the 2 ohms is I2. Now apply the KCL. So I am just applying the KCL at the junction. Once again the same condition here also. There in KVL we eliminate the current source, we keep the voltage source and apply the KVL, we find out the equation. In nodal analysis method, we have to eliminate the voltage source virtually and keep the current source and find out the equation. Why we are doing here like this means here we are applying KCL, so we have to keep the current source. There we are applying the KVL, so we have to use the voltage source. That is a major difference here. So we should not eliminate the current source because we are applying the KCL. So if you are eliminating the current source, we could not able to apply the KCL. So that is the reason we are eliminating the voltage source only. So we are eliminating the voltage source virtually and we are finding out the applying the KCL at node 1. So here the current entering is 3 amps. So the leaving currents are I1, I2 and 5 amps. So now this V1 and V2 is virtually considered as a single junction. So there we consider the two loop becomes a single loop in KVL. Here the two junction we considering as a one junction because virtually we are eliminating the voltage source and considering this two junction as a single node point. That's why we are taking as a one junction actually. So apply. So as per the KCL node, current entering is equal to current leaving. So 3 amps equal to I1 plus I2 plus 5 amps. Suppose the direction of the current is changed, you have to write the KCL equation accordingly. So second, we know the equation is 3I1 plus I2 plus I5. So but what is I1? As per the previous circuit, I1 is nothing but I1 is nothing but V1 by 4 and I2 is nothing but V2 by 2. So as per the Ohm's law. So apply the right? As per the Ohm's law, you apply the equation, then solve this equation. So we'll get the equations 2 equal to 0.25 I1 plus 0.5 V2. So as per the circuit given, so we got 0 V1 minus V2 is the 5. So between the node V1 and V2. So now we got these two equations. Solve the equation and we'll get the answer as V1 equal to 6 and V2 is 1. But in as per the question, they has a current flowing through the 4 ohms and 2 ohms. So once again, as per the Ohm's law, we know the voltage of V1 and V2. Substitute here, then get the current of 1.5 amps and 2 amps. I hope I don't understand this, what I am trying to tell. So if you have more than two different types of source, based on the method, we have to eliminate the corresponding source, and either if it is a KVL, we have to eliminate the current source and make it as a single loop. In nodal analysis, we have to eliminate the voltage source and keep it as a single node, apply KCL, and then we will determine it. So once the virtual line is eliminated, finally after finding out all the equation from the junction, you bring the virtual terminal once again, then the difference node voltage V1 minus V2 we can apply here and write out the equation. So we'll go to the next problem. Determine the current flowing through the 8 ohm, 6 ohm, 4 ohm and 2 ohms resistance using nodal analysis method. So you can see the circuit. Here also you can see, so here also we can see voltage source is given. See, in the previous problem you have voltage source and current source here, but actually in nodal analysis we have to eliminate the voltage source, and the voltage source that is between the nodes we have to eliminate. Then only we can find out the values, the current or voltage to the particular resistance. In the previous circuit we have the combination, but that combination we are eliminating the voltage source, but that voltage source is connected between the nodes. We don't have any resistance. Suppose if we have a resistance is connected between in series with the voltage source, we can apply once again nodal analysis method. We can find out the current flowing the resistance. But here we don't have any resistance connected in series with this 5 volt resistance. It is in between the two nodes. That is two nodes. We can see the circuit so that we have a better idea. You can see the circuit. The direction of the current and the voltage which is between the nodes V2 and V3. So we can think the ground point we are not taking as a ground. You can see this is you can think this is a node, but it is ground potential. So we will not take it this is as a node. So only where the voltage just drops, we are taking that as a node. So V2 and V3 we don't have any resistance, so we are taking that as a super node point actually. But V1 is not a super node because V1 is a drop, but whereas the other point, the ground point is a zero potential, so we will not take that is a node point. So that's why we are taking. So this is a circuit which doesn't have a current source. So we can see, so after the modification, the direction of current is mentioned. We will write the KCL, apply the KCL. So the current from the source is I1 plus I2 equal to I3 plus I4. So I2 is equal to I3 and I1 is equal to I4. So as per the KCL, I1 plus I2 equal to I3 plus I4. So now once you got this equation, write on the equation, rewrite the equation. So I1 is nothing but V1 minus V3. V1 minus V3 by 2. Similarly, I2 is nothing but V1 minus V2 by 4. So this is the current flowing through the 4 ohm and 2 ohm. Similarly, I3 current is V2 by 6 and V3 is I4 is nothing but V3 by 8. So once again expand the equation, then simplify the equation. We'll get 0.75 V1 minus 0.42 V2 minus 0.625 V3 equal to 0. But as per this question, the node V1 voltage is given in the question, 10 volt. So you can have a doubt, sir, V2 is also given, no, in the 5 volt is given, no. Why you are not mentioned that V2 and V3 voltage? Because as I already mentioned, V1 is a voltage 10 voltage is given, but V2 and V3 voltage is, we don't know what is the voltage exactly, because it is a voltage between V2 and V3. So we don't know exactly what is the voltage of V2 and what is the voltage of V3. So it is a the difference voltage only we know, 5 volt, that is V2 V3 difference voltage only we know. We don't know what is the voltage of V2 and V3. But in the case of V1, it is not a difference voltage, it is a voltage at this junction, that is V1 voltage, because the opposite point is considered as a reference point, so that is 0. So V1 minus 0 only, so that is called V1. So V1 is actually 10 volt. So that is the reason why we are not taking V2 and V3 as a 5 volt, because the 5 volt is the difference between V2 minus V3, that is V1 is 10 volt exactly. So as per the question, it is given as V1 is 10 volt. So apply the V1 equal to 10 volts, we will got this equation, minus 0.42 V2 minus 0.625 V3 minus 0.75. Then as per the question, V2 minus V3 is equal to 5. So solve this equation, then we'll get V2 equal to 10.16 and V3 equal to 5.16. So this is the voltage we got at V2 and V3. It is not 5 volt. It is a reason. It is a voltage which is comes after solving this equation. So finally, as per the question, there is the current flowing through the each resistance I2, I4, I6 and IA. So we know I2 is nothing but V1 minus V3 by 2. And substitute the values of V1 and V3, and then we'll get the answer of 2.42. Similarly, we know the voltage of V1 and V2, substitute the value, and we'll get minus 0.04. And then finally, finally I6 ohm says V2 by 6, 10.16, and I2 ohm V3 by 8. So it is 1.69, and I8 ohm is 0.645. So this is the current what we will apply. So you can check the condition what I mentioned, I2 plus I3 equal to I3 plus I4. I wrote KCL equation. You can apply this value and check it out whether both are equal. So might be some fractions values might be changed, but mostly the case will be matches. So that's all about the KCL node. So we solved two problems on KCL mesh and super node, and two problems in super node. There might be some typographical error, and the values after the decimal I took only 2 digits. So people use the digits after decimal 1, after decimal 3 values. So the calculator might give different values. So there is a small fraction is allowed during the calculations. So if any typographical, please excuse. And other things, you just follow the procedure, you get the proper answer. Please cross verify with your own calculation for different problems, then we'll get you the idea. So that's all about the registration. Thank you.